Hey guys, so thank you very much for your feedback on the previous, was it the previous one? I think it's the previous Lazy Sunday video. Appreciate it. I know that I don't often do the talky things anymore, straight to camera, and I'll try not to because they're not that interesting, are they? I'm sure you want to get straight down to the electronics. Anyway, I appreciate the feedback, and it sort of made me realize that maybe I don't need to change anything at all. So I'd previously asked, should I create a schedule? Do you want me to do it on certain days? And I guess I don't need to, so I'm not going to bother. We'll just continue as we are. The thing is, I do my projects. I do the projects that I do on YouTube because I'm doing them anyway. I like them, but I video and put them up for you. So if you're happy with the way they're going out, then I'm also happy. So let's carry on, shall we? Hey guys, so welcome back. We've already done the little intro bit. You've already seen me do that thing. Anyhow, we're going to be doing a Lazy Sunday video today. I'm going to be building a kit. Now, I wanted to show you that some new ones have come in. I can't remember if I've shown you these before or not. Anyway, there's this, it's meant to be a wall touch sensor, but we're not building this one today because I just think I haven't figured out why I even bought it. It doesn't seem like something I would buy. Oh god, it's going to spread bits everywhere. So it's just replaces the switch in your wall, which seems really odd and not something I would do. But it's here, so I may try and use it. But it's going to have, I don't know what it's going to be connected to. We'll have to find out, but it seems a little dangerous to be messing around with mains electricity. So that will be something we cover at some point. If anyone's seen one of these before or used one, made one perhaps, you picked up the kit, then do give me some advice because mains electricity frightens the dickens out of me, if that's an expression. Another thing that came in is this. I don't remember buying this either. This is it's an audio breakout board, I think. I mean, it doesn't have an IC on there. It's literally like a path management thing. So odd. I don't know why I would have picked that up. It must have been to do with one of my audio projects, but again, not something I'll make in a Lazy Sunday video. This one is a mystery, a complete mystery. I have no idea what it is, where it came from. I might have some luck Googling some of the numbers on here, I think, but it says SMT DIY. I know some of you tell me to look at the, try and do a Google Translate on the characters, but I don't have my phone with me. I'm going to rectify the fact that I don't usually have my phone with me when I do these soon, but I'll show you the schematic and I'll let you see if you can figure it out. So that's what it is. We've got a 4060 there and we've got a crystal. So this is going to divide down the output. I can't remember what Q7 divides down to. So it's a 4.1934 94304 megahertz crystal, and then it's got some LEDs here, and on the board itself, if we have a look at that, oh, there we go, it's powered by two AAA batteries. I don't really understand what this could be. I'm gonna have to Google it and find out. I'm gonna have to maybe go on all of the places that I buy things and try and look at my purchase history, but I don't know. I've got pages and pages and pages of history on Amazon. Well, I do on Amazon and on AliExpress, so it's difficult to find out what things are, especially when pictures can be kind of misleading, and that's what I'd be going on. I've also got this, which is one of these LED cubes, 3D LED cubes, but it's a shield. This one says it's made by IC Station. However, I didn't buy it from IC Station. I bought it on AliExpress, so they haven't given it to me or anything like that. And it's just being driven by two 74HC 595s. So really, really simple, in fact. So it'll be an interesting one to build, mainly because of the structure of the LEDs. So not today, though. There's too many things to do today, so I can't be messing around with that thing. We're going to try something a bit simpler. The reason there's too many things to do today is because Doctor Who was on last night and I missed it, and Sense8 began again, I think. which is basically like a big orgy TV show, I think. But I really enjoy Sense8, so I'm going to be looking for that this evening. I can't remember whether it's on Netflix or on Amazon Prime. I'll have to try and Google that and find out. So we're going to be building this. This is the function generator, I think. Is it? I'm not sure. Let's see. Let's pull the board out. So this is actually the project. Oh no, wait. Before we do that, I had some other things come in. What have I dropped on the floor? Oh, one of those. Okay, good. I had some other stuff come in I want to show you. So this is sort of a mini post bag really, but the binary clock. I'd been thinking about it for a few days and I ordered some LEDs. These are from the UK, so they were expensive, but there's 50 different colored LED. No, actually there's 5 different colored LEDs in here and there are 50 in total. So some nice ones. We've got some red, green, blue, yellow and white. So they'll make for nice indicators, better than the usual white ones I normally use. I've also bought some 6.8 meg ohm resistors. They're for the 1 Hertz timer with the 6050 and the 4027. And these are the 4510 ICs. So I've bought some of those, hopefully enough to make a single prototype and figure out what I've done wrong. Theoretically, in my head, I've figured out that I have designed it wrong, but I need to test it because I'm not quite sure how to fix it. So I'll figure it out. But I don't want any spoilers on that because it's a thought experiment I'd like to do myself. What was it? The ESP8266 outdoor temperature sensor that I was building. Well, I brought that inside so I could use a different diode, and the diode I wanted, MOSFET. And the MOSFET I wanted to use was the FQP30N06L. Lovely catchy name. Anyway, that arrived, so I can now bung that in. But while I was waiting for that to arrive, because it took forever, because I didn't want to spend like a few pounds on one, I picked up some relays, and someone very kindly bought one off my little Amazon wish list. And it's this one here, which is the wrong way around. And it is a 3-volt relay. And I was thinking relays can handle a lot of current, and 3 volts I can manage with an ESP8266 or with the Arduino Tiny 85 thing that I'd rigged up, and have it run off a smaller amount of voltage. So I wouldn't have to have 4 batteries. I could just have a few, take advantage of a perhaps lower current sleep mode, maybe using one of these ICs, which is the TPL5110. That's that really micro current timer. So no, more than nano current timer essentially. So it's 350 nanoamps this one takes to run, and it can drive a MOSFET, so that MOSFET could then drive the relay. So that would be pretty cool. Anyway, I've got a few different types. So this is another one, solid state relays. This is solid state one. It's that's the wrong way around. A Cridon SD12415. I think I picked up the wrong one for this. I think that might be a 12-volt one. We'll see. I'll play around with them. And then we've got another one here, which is does it have a part number? IM01TS. And it should handle 2 volts. And I believe it's a 3-volt relay. Anyway, I don't know about over voltage on these, so if anyone knows about over voltage on relays, I'd love to hear about it, because I'm hoping to put about 3.64 volts maybe in them, but I might just have to use a diode to reduce that. And I also picked up one of these. This is one of those Foztech or Photech. I thought it was Foztech. It's not, is it? One of these solid state thingies, and that's because I want to run a lamp off one of my projects, but we'll come to that at some point. I don't know if it's really going to happen, we'll see. Anyway, so it's just like a mini post bag, I guess, except for I didn't take them out the bags. Okay, so this is what we're building. Finally get to it, like 20 minutes in or something. I don't know how long it's been, probably 20 minutes. Anyway, we're going to be putting this together, and we're going to do it quite swiftly because I don't want to hang around. So a function generator. Let's do a quick little drawing, shall we? Because everyone likes a drawing. So this one It doesn't have any instructions on here that I can read. However, let's just skip over a page here. So we're probably going to be looking at getting square waves, which will look like that. And we're probably going to be getting sine waves, which will look like that roughly. I mean, they don't look like that because that's terrible. And sawtooth or triangle ones like that, with a more pronounced edge at the top. I think that's probably what we're looking at getting. Oh, do you know what? It's on the solder mask, isn't it? There we go. So we've got square wave, sawtooth, which looks a little different to the way I've drawn it, and the sine wave. So we need to put 12 volts in. Damn it. Okay, I think I can find 12 volts. We'll see. Anyway, let's get the components in. So we want to do the small components first. So let's start with the resistors. I need a multimeter. Where is my multimeter? There we go. There's a multimeter. So this one will be do fine. Now we're going to use the VC97 that someone very kindly got for me. So thank you very much again. And that is a 32 kilo ohm resistor. Luckily the solder mask on here should tell me where that one goes. Okay, so there should be two of these. What does that one look like? Ah, there's some more in the bag. Good. So that looks like that one. So 33, 33, 33. So there are three. Okay. And that's all of those ones. So let's bung those in. I've got my soldering iron already heating up. So that's that one in. Let's bend those back a little bit. And the next one. And I'll get my scope out so we can take a look at this. We'll do that. I'm not trying to rush everyone just because I want to go and watch Doctor Who and Sense8. I'm really not. I will take my time and make sure that I get this done properly. Although, you know, there's probably going to be mistakes, you know me. But I will try my very best not to make too many mistakes. Or at least no, I won't try and repeat the same mistakes. Now, they are the same, aren't they? Yeah, they are. Or are they? Because there's another one there. And there is another 33 on the board, that's fine. We're all right, don't worry. There hasn't been a mistake made already. So the binary clock. I thought I'd talk to you about that very quickly just because I'm here and all we're doing is putting in components. Well, the binary clock, I don't mind not making it binary. It doesn't have to be binary at all. I just thought it might be something you guys might be interested in making. Or anyone might be interested in making, so that's a 10K. I just fancied making a kit, and that one seemed like quite an interesting one. A clock with pure CMOS sounds interesting to me, without a microcontroller, so no need to program it, which makes it easier if I want to distribute it. It means no programming for me, no mass programming of chips. And also like an interesting logic experiment, I guess. And I'm not going to look up any sort of previous projects if anyone's online. I refuse to do that because I'd rather sort of figure it out myself to start with. I mean, it's only like putting, I don't know, little bits of Lego together essentially, because I can read the datasheet of the IC and figure out what its capabilities are. If I know its capabilities, then I can go ahead and hook it up with another chip that I know its capabilities. So it's not actually a very difficult project. I mean, it's a thought experiment really, because I have to go through and figure out how I'm going to get all those different digits displaying. I've got an extra resistor. Have I? I mean, that's oh no, hang on. Is that the 200K one? It doesn't look quite the same as the others. Let's find out. Yes, it is. 200 ohm rather, not 200K. Let's just double check. 200 ohm? Come on. Yeah, it is the 200 ohm one. Yeah, so I want to figure it out. I figured out how to count up, but then there's the blooming 24-hour thing. So what happens when you get to 24 or 29, 23:59? Well, that is the difficult one. So that's a 102. That is a 103. So that's what I'll be trying to figure out. And I'm not quite there yet. I want to breadboard it up, and I think that will help me figure it out. There's another 104. This is, well, that will be easy to find. So 104s. I'm going to pop this in the electronics jaws so that we can put this together. That's a 104 as well. And the 103, in fact, let's just spread the legs out on those a little. Yeah, I'm looking forward to the binary clock. I'm looking forward to having a kit of my own. I think that's really exciting. I can't believe I never thought of it before. I didn't even think of it. Someone else thought of it for me. I don't know, I'm trying to claim credit for that now. That's a 102. And that is the 103. Yeah, no, it wasn't my idea, so I'm not going to claim credit for it. But the person whose idea it was, you can have a free kit if you remember once it's made. I will send it to you for free. Otherwise, everyone else is going to have to get it at cost. I'm not going to make a profit. I'm going to sell it on Tindy, so I will not make any kind of profit whatsoever. Well, I don't know if I can help not making any profit. I'm sure there'll be at some point at which I'll get 50p or something like that, but I will buy the parts, figure out how much it all costs to put together, and then charge everyone accordingly. Right, let's pop that one in as well. This is not all the low components, but we'll make it work in the jaws, which are just here. And tighten that up. Oh, I say tighten that up. There we go. That should be fine. So let's get soldering. I'll pop this out of the way for now. And you guys can come in a little closer, can't you? Right, so let's get this party started. I don't feel like I've done one of these for a while. Was it last week? It doesn't feel like it was last week, if it was last week. The last one might have been a live one, I'm not sure. I did enjoy that. Was it live? I'm not sure. But it was good. I haven't got any plans for a live stream coming up, but I might try and think of a reason to have one, because I did enjoy it the last time. I don't know, if you guys have got any suggestions, that would be good. I'm sure there was something I was saving for a live stream. But I am not sure anymore. I did want to do some Commodore 64 programming. Would that suit anyone for a live stream? Does anyone want to see that? I mean, if all else fails, we can just play computer games on the Commodore 64 instead. That also suits me. I've been looking up how to do parallel port programming recently. I've got this old laptop. It's a Toshiba 200 CDS. It's not really that old. I mean, it's 1994, I think. And it came with Windows 95 on it, and I've put Windows 3.1 on there, which I might put back to Windows 95. But I wanted to do some parallel port programming, so it has a parallel port on there, and I wanted to treat it like I/O, like you would on an Arduino or something, or a Raspberry Pi is probably more accurate description, with a full operating system that interfaces with those pins. So I thought that would be cool, but I haven't actually found a piece of software to do it yet, or a way to do it in DOS or anything like that. And this is an oldish laptop, so I think it runs at about 100 megahertz, maybe even less than that. I'm not entirely sure. We'll have to look at the specs when I'll do a little video on it. I'm going to replace it's got a hard drive in it. I'm going to replace the hard drive with a CF card, which is a compact flash card. And you can get CF to IDE adapters, which are rather cool. Right, so that is all of them soldered. So let's get those ones cut off, and then we can pop the rest of the components in. Again, does someone want to point me in the direction of a 3D printed magnetic bits picker-upper? It might be like a nuts and bolts holder or something like that, but it would be really nice to make something like that. I could just design something, but I'm so lazy. Well, that's not even soldered. That is just terrible. Let's just sort that out quickly. I just flood a lot of solder on there, it should be fine. There we go. That is an awful job. Not paying attention when I did that. Yeah, someone wants to point me in the direction of something, or even something you can buy, I don't mind. I can get it on Amazon or something. But these flying everywhere isn't the best. Do you know what? Maybe a magnet that's stuck over the top of here. Maybe that would be really cool. And that's sort of caught everything coming off. I know magnets aren't really appropriate for all electronic endeavors because you might have some sensitive stuff on your board, but it'd be nice to have it for little things like this. Now, next up, let's get the IC holder in. No, are any of those? Yeah, some of those pins are bent. Let's rectify that quickly. There we go. You should all slot in now. There we go. And the bigger components as well. So we've got, oh interesting, we've got some terminals here and a switch and some potentiometers. So let's get these potentiometers in. A 203 and a 104. So the 203 would be the 20K and the 104, so 10 with 4 zeros is the 100K. So that one will go in there. Okay, and I think we're probably all right with that. Let me get some blue tack. He says blue tack when it's really rubbish tack. Yeah, I went there, I said that. Nope. Right, that should hold it. Let's get those soldered in. Yeah, I need to invest in some better blue tack, I think. Wouldn't it be nice if there was some kind of putty that didn't like go funny with heat, or I'm not really sure what there would be, what kind of stuff that, oh, we haven't soldered the IC socket in. It's pretty much in there, so let's just go for one of those and just check on this side. No, not quite. There we are. Okay. These ones are fairly easy. Oh, fairly easy to do. I say that and then immediately screw it up. I love soldering IC sockets. We need to clean the tip a little bit. There we go. Can fly through these now. So what are you guys building? I know I show my stuff off fairly often, and some of you I know, some of you have got YouTube channels and I watch you. Oh, there's a guy I watch on YouTube. He's not got many subscribers, but deserves a few more. So if you want to head over and see his channel. Now, I'm sorry if I've got it wrong, but it's Stephen Ludgate. Yeah, Stephen Ludgate, I think that's right. I'll put a link in the video description, or I might put his face up here or something like that. But yeah, he's got some really interesting videos and he seems like a smart chap. Probably smarter than me, if I'm honest. So don't desert me for that guy. But he seems like a nice chap, and he gets his daughter involved in his videos quite a lot, which is cool. There's another channel called Micro Monsters, and they get that dude gets his daughter involved, which is awesome as well. I'm a big fan of kids doing electronics. I'm always my mate's kid. I'm always threatening to get him into electronics. He's only 1 and a bit, but it's never too early to start, is it? Why won't that one go in? Darn. Okay, hang on a sec. These appear to be a little bit bent around, so I'm gonna have to bend the pins a little. There we go, that might work, hopefully. There we go, yeah, that's better. And then we also have a switch that goes over here. Does it? I don't think they've given me the right... Oh no, wait, they have, it's there. That's where this big old potentiometer goes. So that switch needs to be held in. The other ones are fine. So let's hold that switch in. And then this big old potentiometer needs to be encouraged into place. Now, is this going to hold in here? If I hold it off to the side a bit. No, it won't. No, okay, we're going to have to just do this in an old school way. I just hope things don't fall out. Simple, right? I'll pop a little blue tack under those terminal blocks just to hold the thing there. And then we'll figure it out. It's probably out of focus now, but you'll just have to bear with me. Yeah, Stephen Ludgate. I can't remember why I found his channel, but I can tell you he recently did an awesome little Groot 3D print. And do you remember that LED one that I did? Well, he did it first. He did it like 2 months ago, and he did it with his daughter and probably did a better job of it. He was certainly better at wanging it around than I was. And someone I think mentioned in the comments for that wand. Oh, that was the last Lazy Sunday I did, wasn't it? Oh, now I remember. Someone mentioned in the comments what the little characters were, and that the text moved and had various pages. It was interesting. So, I mean that's a little bit off, isn't it? But I can bend it. There we go. That's fine. That's good. The switch. I haven't soldered up that switch. Let's get that done. Really, I need to sort the light out in here, don't I? Because every time I put my hands down, it's putting shadow on the board. You know what, I should have just put a little bit of solder on here just to get it started. There we go. Perfect. He says, I really need to stop saying perfect because pretty much none of these ever come out perfectly. But we are done. I just need to pop the chip in, which, by the way, is an ICL8038. Don't really know what that is, but I assume it's a chip that does this kind of stuff. Oh, we need to roll the chip. Roll in with my homies. Not sure anyone says that. And there we go. That will fit in nicely. He says, come on. There we go. Absolutely brilliant. Okay. I'm going to get something I can power the damn thing up with. Where is power going in? So ground, that's ground for the scope, and these are the signals, and then we've got plus or minus 12 volts. I'm not sure where I'm getting that from. I'll figure it out. I'll be back. Right, so we're all set up down here, hopefully. I can't afford one of those nice desktop scopes, so I've got one of these ones where it's got a really long back to it and it weighs a ton. One day I'll pick one up, but at the moment this one still works, so it's probably okay. This is what I'm going for my 12 volts. I've got 8 AA batteries. I don't know what they measure at the moment. Let's find out. Okay, I don't know if you can see that, but there we go. Let's see what we've got. 10.56. That'll have to do. I don't know if it absolutely needs 12, then I'll look for another solution. But we could try 10. That might be enough. I don't know. We'll see. We'll give it a go anyway. Now I'm going to be doing that. I've got some of these crocodile wire here. I can't find one of the connectors. These for the, what is it, PP3 connectors. I don't have any, so we're going to have to do it without. Right, so we're all hooked up with power and we have a red LED on, which is a good sign. We've got the ground for the scope over here, so I'm just going to hook up my probe to it, and then I'm going to hook my probe into channel 1, I think, because that's what's already on the display, hopefully. It's been a long time since I've really used this scope properly, so you'll have to forgive me if I've completely forgotten how it works. Right, so what are we on? So this is DC, and how do we set what we're triggering on? Add, minus, select trace, no. There we go. So we're triggering on channel 1 over here, so that's fine. So I should be able to just take the end off here and plug it into one of these and see something. Okay, that's probably square wave, yeah. And this is the sawtooth, and that, I can't see it, but that's probably because we're zoomed in. Am I on my X10? Yeah. Let's find out. There we go, that's a bit better. I'd sort of forgotten how to use the scope. So we've got the sine wave there, and I think if I use this trim pot, I can change the time base, essentially. So this is changing the frequency, which is cool. And then this should be sawtooth just here. And again, we can change the time base, which is nice. And then this final one should be a square wave. Oh, it's gone off the screen a little bit. Let's change my... Oh, no, up. Let's bring that up. Down one more, I guess. Other way. And there we are. Oops. There we go, that's better. I wish I had something that did that for me. Anyway, there we go. So it looks pretty good, doesn't it? Actually, that's quite clean. Just move that over a little bit. Sorry about that. The guy was playing guitar next door, so I had to stop the video for a second. Let's have a look at what the little potentiometers do. There's a switch on here as well, so we can find out what they do to our signal. So if I throw in the square wave again, we already know this changes the frequency. And if I switch the switch on the board here, you can see that it's changed that frequency significantly. So what we've got here, we've got these two capacitors. Do you remember there was a 102 and a 103? Well, they're part of a timer circuit, so it switches between those two, and it allows you a greater degree of freedom on this. So that's what those two switches do, or that switch rather. And then we've got two potentiometers. So the first potentiometer, start with this one over here. This one changes the duty cycle. So that's the time that it is off and on. It doesn't go, it's not full scale, it's part scale. So you'll see that that changes. And we can see that on the sawtooth and also on the sine wave. So it's changing, I don't know if it's called duty cycle in this. It's the when it starts going on and when it starts going off. So you can create this these different patterns. So the other one, the other potentiometer on here is a bit of a mystery. I'm going to call it the Curvaceous Potentiometer because I don't know what it does. It doesn't seem to do anything with the triangle wave or sawtooth or whatever you want to call it, or on the square wave, but on the sine wave, it's changing how curvy it is. Let's zoom in on that one a little bit. Zoom in, I mean, change the volts per division. And then bring it back down. And you'll be able to see the difference. So if I then wiggle on this potentiometer, you can see, I don't really know, I don't understand enough about frequencies to know what that is doing. I have no idea. Still, you guys are always great at telling me. So this is what is that doing? It's changing. This is the curvaceous one, and this is essentially the duty cycle one. So this is the square wave changing the duty cycle. Same with the sawtooth, look. And then we've got the curvaceous one. What is that? I mean, there's a bit of noise there. So look, it's changing how curvaceous it actually is. Let's put the duty cycle back to one that looks a bit more like a sine wave. There we go. And then I can change, is that the DC offset maybe? I'm not sure. Anyway, it's cool. I'm quite happy with that. So uses for this, testing a scope, I guess. You can use it as something that does PWM. So this square wave one would be very useful for that. It's sort of, you can change the time base, so you can dim an LED or make it brighter, I guess. The sine wave and sawtooth probably not going to be all that useful for that, but brilliant to just throw on a scope and check that your channels work. So yeah, a lot of fun. I enjoyed making that. It was cool. All right, I'll see you guys again next time.